Hello, my name is Leen, and I'll be going through the Ensemble Solar Wind notebook, starting with the Enlil notebook. First and foremost, this notebook reads in Enlil model data from the CCMC as a Kamodo object in order to perform visualizations and conversions so that we can evaluate the data. There are going to be some exercises throughout the notebook, but I'll just be running through each of the cells. Now, obviously, first we have to go through and import all of the packages and libraries that are needed. Kamodo is going to be a big one here, and Kamodo allows for the visualization and modification of space weather data, and it allows us to run through simulations so that we can evaluate such data. Now, when it comes to this Enlil notebook specifically, Kamodo serves a variety of roles by commodifying the CCMC data for either the solar min or the solar max. That would be up to the user. Not only can we perform the appropriate conversions to plot in the optimal coordinate system, but we can also visualize the data. So we'll go through some examples below. So here's reading in the data from the CCMC. And like I mentioned before, the user can either choose the solar min or solar max by commenting out which one they don't want. We're going to be going through solar min in this video. And then we just take a look here at the registered functions after commodifying the data. You can see that we take in all of the variables from the data instead of one, so that we can essentially choose which ones we want to visualize. Then we get into basic spherical visualization. We can either choose 1D or 2D cuts based on what exactly we want to evaluate from the data. So we make 2D cuts by fixing on one coordinate, and we make 1D cuts by fixing on two coordinates. Now below is an example of a cut, a 2D cut in this case. And once again, the user has the option here to select which plot exactly they would like to see. For example, if I wanted to go and try one of the 1D cuts, for example, with rho and theta, I can just comment it everything else out and run the cell. And there's our model. Now with exercise 1, there's going to be some commenting taking place, but essentially we're going to be plotting new variables in spherical coordinates. We're going to be making some pretty similar cuts, but there's some more applicable variables that we want to apply here and visualize in physics. For example, rho squared is much more useful to us when we are assessing the data than simply rho, and this is an example of that. This is a plot of rho squared. Now, here's where we really get into the whole reason why we read in CCMC data is looking at the magnetic field. Now, it has unsigned and signed components, so we have to combine them with pointwise multiplication. That's not too bad. And then we start with the conversions. Here's where Kamodo also is extremely helpful when we are reading in data, because it applies conversions for us fairly easily so that we can get straight into plotting everything. So we perform the coordinate transformations. Right now we want it to be in Cartesian. We originally had it in spherical. And as you can see, this walks through 4.2 walks through each of the conversions step by step. And then finally, we have the magnetic field in Cartesian after all of the conversions. Once we start plotting in Cartesian coordinates, as you can see, we get very beautiful shells here that allow us to very easily visualize and notice any patterns in our data. So this is a plot of rho and a theta shell. and you can adjust the angle as needed. This is a shelf fixed at a particular angle. And once again, here's a shell fixed at a particular angle for theta. We can put them on the same subplot, and this is where we really start to see all of the visualizations that we have so far come together so that we can notice any patterns or we can notice any impacts on one to the other. Now, the most difficult part of this notebook is field line tracing, and getting the tracers to work allows you to select very specific points here. So creating the tracer isn't too bad. We're using the enlil data and the Kamodo function. But once we grab the two exact points that we need and plot them, it's very easy to see here the field lines that we wanted to trace. It's just very important to select very specific points, and it's very much a trial and error process. Now, tracers can obviously be very messy to work with. Sometimes when it gets very close to the equator, it can take a long time to run, or the field lines kind of get blurred together. But then you can see very cool patterns, and in this case, unfortunately, only a third of the seas are traced. So with more additions, hopefully all of the field lines can be traced in this case. Thank you, and this was the enlil model. I will be going over the core Helm notebook in another video. Thank you.